My name is Frank Fan. I'm partner solution architect from AWS. Before I talk about today's content, I'd like to share with you a story from Joe. Joe is an infrastructure manager look after a large virtualization platform for a large organization. It was a Sunday afternoon. Joe enjoyed a beer and a barbecue with his close friends and family. And he got a phone call from a support team. Joe, sorry to bother you on weekend. We have a very serious situation. The water pipe just bursted in data center, and we lost power and lost connectivity to all our racks there. What would you do if in a similar situation as Joe? The first idea Joe come up is, I have DR. I have the DR plan logged in my cabinet in my office. But wait a second. When was the last time you test your DR plan? It was 12 months ago. Joe have no confidence it's going to work. And only option he left is finger crossed. Monday morning, he rushed to office and the CEO asked him, Joe, I heard you got a notification 12 hours ago. What have you done since then? Joe have no word. Let's see why it's a challenge for lots of organizations about DR. In Joe's scenario, basically, I would like to see it's just because the DR plan it's quite complicated, and in some organizations you just don't know where to start with. Today's talk, I want to share with you some framework and ideas, and also some technology to help you come up with DR plan, and also you have some solution to help you. Let's start with the approach I called ISP. I stand for impact. You need to analyze business impact with your application owners and challenge them what's your RTO and RPO. RPO is recovery point objective, which means how much data you can afford to lose during that interval. And RTO means your recovery time objective and how quickly you want to restore your service since the disruption. Once you get agreement with your business owner, and then you should come up with strategy. There's no one size fits all. Perhaps you have multiple strategies to meet different requirements. And last but not least, you need to have plan. It's not a once-off task. You need to have the plan regularly updated to keep track of the progress of your business requirement, and it's a living document. It's ISP. All right, assuming we already have that requirement, where should we do? Now I'm going to share with you some 4 different approaches to help you to start with. If you look at this bar in the left-hand side, this is a active, which means you have 2 environments up running all the time, and it meets the best RTO and RPO, but it's also the most expensive one. Another approach, you can start with warm standby. You have that infrastructure and data set already up there. It's warm, it's ready for you to consume. In the event of disaster, you simply just scale out this environment to meet your need. The third one is pilot light. You have that data set already synchronized, but you may not have that infrastructure. You can provision that infrastructure on demand. Last but not least, if your workload have very loose RTO and RPO, for example, hours, you can use this approach, have your data backed up, and restore afterwards. Joe evaluated these all 4 approaches, and he decided to go ahead with the last approach. Today I'm going to talk about how you can leverage VMware Cloud on AWS to meet your objectives. Let's have a quick overview. This is a service, cloud service, delivered, configured, managed, and also supported by VMware. VMware will deploy this software-defined data center stack on top of AWS infrastructure, so it's running on bare metal hardware. It's not nested virtualization. And then engineering team from both VMware and AWS create that high bandwidth, low latency link. As a result, you can leverage over 130 AWS services to modernize your architecture and also bring your operation to the next level. Let's drill into details about this connectivity. So as part of onboarding process, you will have VMware have permission to provision elastic network interface. That's icon on the right-hand side. That's a round icon. That network interface will be presented directly back to the physical ESXi host. And then VMware will update the routing table to ensure these two worlds can communicate with each other. And also that's a green box, CGW, that's a NSX edge. It's acting as a gateway between your customer workload and external world. Now we have this routing table configured, two environments talk to each other. But what if you have failure about the virtual appliance, CGW, or you have failure about hardware? VMware will start another CGW in the second host, and then automatically update the routing table for you. You can still have that connectivity. So it's very transparent for end user. We go back to the scenario we mentioned earlier, 4 different approaches. Let's start with the first approach, active. In this case, we introduce concept stretched cluster, which means this is a deployment mode. You have multiple virtualization hosts deployed into a physically isolated location, but you have only one logical vSphere cluster. In this diagram, you can see the physically isolated location is AWS availability zone. We call AZ, AZA, AZB. So AWS has regions. Each region has multiple AZs, and each AZ have redundant power, redundant facilities and networking. And each AZ consists of multiple physical data centers. But even that, you may experience a very slim chance about a failure of the whole AZ. If that happened, it's very simple for you. VMware HA event will kick in and then start that workload on the alternative AZ, which is AZB on the right-hand side. And this is fully transparent for user because we all know how HA works and no human intervention. We covered active. The next scenario I want to cover is for warm standby or pilot light. In this case, if people familiar with SRM, Site Recovery Manager, this is a very similar concept. You deploy Site Recovery, which is an add-on to VMware Cloud on AWS, and then you pair up your on-prem environment and VMware Cloud on AWS. You have flexibility to control which site you want to protect. You can use VMware Cloud on AWS to protect your on-prem environment or vice versa. Another interesting setup is you can set up the VMware Cloud environment in 2 AZs and protect them each other. Okay, so this is a very simple approach. You basically have that simple setup and very easy to maintain for ongoing basis. The last approach I want to introduce is backup and restore. If you have that hours, RTO, and RPO, you can go down this path. As you can see, left-hand side, you have on-prem environment. Right-hand side is public cloud. Step 1, you need to have data backed up. You can continue using the product you already have. Vim, Commvault, they all have supported this approach. This solution is supported, it's called Cloud DR, provided by Dell EMC. You leverage Dell and EMC product to get your data backed up, to S3 bucket directly. That's step one. Once it's done, actually you can see you only pay minimal infrastructure cost like S3 capacity, and also another EC2 instance, CDRS, that's a control server to control the data set. That's all. In the event of disaster, you for example, lost an on-prem site, and you just simply use a console to provision the VMware Cloud on AWS infrastructure on the right-hand side. Alternatively, you can go use some automation approach like CloudFormation to automate this whole process without human intervention at all. And then you import an OVA, CDRA appliance up running on the newly created cluster. Step two, and then you set up connectivity with that control server's CDRS as well as vCenter. Now you can go with step three, and then you can directly restore. So as you can see, last step, you have VM up running, and you just simply switch to record, and incoming traffic will go to your new environment. As a result, you only have a low-cost, on-demand DR target. And then you can easily fill back when the primary side recovered. That's the end of my talk. Thank you very much.